going to show you a new way to think about points. Okay, it's a new way to think about points. Now, just because it's new doesn't mean it has to be hard, but it'll hopefully be kind of intriguing in the next 30 minutes or so that you'll realize, oh my gosh, I can actually describe a point like 6/8. I could describe it with actually some new numbers. Now, you can just watch if you want, but if you do want to write something down, I'll never stop you from doing that. This is just a little preview. It's actually kind of a preview of almost the whole chapter. And again, sometimes just listening is just as helpful. That's the point 6/8. It's been that point since the first time you graphed it, probably back in junior high. But how else could I basically get to that location? How else could I tell someone to arrive at that spot without just moving 6 units horizontally and 8 units vertically? Well, if you think about it, you could get to that location if you just move, if you just go directly to it, if you just go basically in a diagonal. The problem is if I tell somebody to move so many units in the diagonal, I would also need to know what angle. I would also need to know what angle to tell them to go or to rotate. But the good news is that we have a way to do that. Now, this diagonal distance, I'm going to go ahead and just tell you that it's r. And you've actually seen it that way before, but we're going to call it r so we don't have to keep saying diagonal distance. So, how could I determine r? How could I determine theta? If I know these two distances, how can I determine r? How can I determine theta if I know these two distances? Now, you guys have been through some math in the last almost half a year, and what you just saw me diagram here maybe isn't like a complete surprise. I know that you can tell I diagrammed a right triangle. So how would you find this value of this right triangle? How would you find this angle of this right triangle? Do you want to have like a little discussion with your neighbor? You can talk to them. How would you discuss with them? How would you find r? How would you find theta? It's all right. Again, you can discuss with some math with them. Lively conversation. Now, if you had discussed this with your neighbor, if you had discussed it with them, what would you have said? I'm not going to put somebody on the spot here, but anybody want to input a little bit here? How? What would that look like if you were going to use the law of sines?
Find r, Pythagorean Theorem, and then equal to 90, and then find theta.
Okay. Now, it's funny, well, not necessarily funny, but you actually said that, first of all, we would have to find r. Was anybody going to give any input on r? Do you want to run with that? How would you find r? Or pass it off here, Morgan? All right, so Pythagorean Theorem, sometimes people are kind of like, is that all there is to it? Yeah, okay. If we're going to find r, why don't we use a pretty basic concept to do it? Why don't we use Pythagorean Theorem? And of course, r squared equals 6 squared plus 8 squared. Again, you can just watch if you want, or you can write this down if you want to. It turns out that r squared equaling 6 squared plus 8 squared is, let me make that a little brighter, is actually just 36 plus 64, which turns out to be a pretty nice number for this problem of the square root of 100. So we get a nice little round 10 there for our value. Now, Anthony, you were right. You could use the law of sines. let me challenge you guys, though, to think about how you could find theta by just using the original numbers. I'm talking about the original 8 and 6. Because we could do it a little simpler if we just use, Thomas? Yeah, that's really good. Now, if you happen to have not thought about that when you were talking to your neighbor, just think about it with me, because everybody did this really well a number of months ago. You guys would have said that tangent is always opposite over adjacent. And basically, a little inverse tangent of 8 over 6, and you got yourself an angle of 53. And that's pretty sharp. Now, again, you could have used lol signs, and quite frankly, you could have used any of the math that we learned. But this is probably the simplest way. Now, here's what I want you guys to understand. This is like the new idea. You can continue to listen. If you're just listening, keep listening. If I tell someone to rotate 53 degrees and move 10 units, I will get them to arrive at the same point. In fact, if I take these two numbers, 10 and 53, I can record them as a new version of that point. The numbers 10, 53 is a new way to describe a point. And so that you see it, it uses an radius. That's why we call it R. It uses a radius, in other words, 10 units, and an angle. And we get to the same point. And we also kind of open up a new can of worms, which is called polar mathematics. Polar mathematics is the idea of thinking about points as a radius and an angle. And that's what we're going to start today with our new chapter. Okay, now let's kind of go back a step. And if you haven't written anything down yet, you probably want to start to do that now. But let's just kind of go back a step here. Let's talk about this idea of a polar point. Also, if you're saying, why polar? Like, what is that all about? You'll find out here in just a few moments why we use the word polar to describe this type of math. First off, though, we have the notation for a polar point. We have the notation. And it won't take you long to get familiar with this, okay, because it actually uses two ideas that we've already discussed. It uses an R and a theta. Again, a polar point is always described with a radius and an angle. And your brain will kind of have to sort of reprogram itself, at least for a few weeks, to think about when you have two numbers, to think about them as a radius and an angle. You also will kind of have to reprogram your brain, at least for a few weeks, on how to think about graphing these points. And the place that we're going to graph them is on what's known as the polar plane. Now, the polar plane is not, we're not talking about that kind of plane. Okay, what we're actually talking about is a two-dimensional surface. This is the Cartesian plane. Again, you've grown up with it, and it's still here. But we're going to temporarily sort of say goodbye to it because we're going to talk about the polar plane, which is another two-dimensional surface that has some characteristics to it. Let me show you. The main characteristic it has is what's known as the polar axis. Now, the polar axis is 0 degrees. So instead of it being the x and y axis, there's just one axis. It's called the polar axis, and it represents 0 degrees. Honestly, probably the way you would have expected it to, like going to the right. This point in the middle, this place in the middle, is not the origin, but rather it's the pole. And that's why we call this polar mathematics, quite frankly, because the pole represents the middle. Now, you say, what do you mean the pole? Well, a pole is basically something that we can do circles around, that we can kind of go around. And that's exactly what happens with our polar plane. We end up drawing what I call concentric circles. These circles will represent our radii. These circles will represent our radii. Now, are you drawing a few? And how does it look? It's interesting to see if you can draw circles that aren't sort of lopsided. Mine got a little lopsided on the left here. But are you starting to see the two-dimensional surface? It's a place where we can actually plot points. Which is what we want to do now. Now, like I said, it's a new way to think about numbers, but it's neat. It's kind of a little bit of a brain break from what we've been doing. If you have the point 2, 120, you're going to have to think about rotating, and then you're going to have to think about a distance of 2. Now, you might notice I actually kind of said that backwards, which is normally what people do. They first will think about the angle, and then they will move out 2 circles. So where's 120? Well, I'll tell you, maybe before we do that, we could have done this, which is never a bad idea, which is to put a couple checkpoints into your angles, the same checkpoints that you've always had. So let me encourage you to maybe mark up your polar plane a little more, 90, 180, 270, the same numbers that you've seen. And that might make it even a little easier to think about 120. Okay, now 120, it's just a sketch, but it's probably about right there, right? So you can kind of sketch 120. Most people draw like a line, whether you make it solid or dashed, doesn't matter. But I'm simply going to then move 2 units. I'm going to move out 2 circles. And we get to the point 2, 120. I'll even label it with the letter A, because we're going to put some more points on here. Okay. Well, for now, that's all we need to do with that. For negative 45. For negative 45. Now we're going to start throwing some negative numbers around. But my hope is that you'll continue to think the same way we've done before. I hope that when you see negative 45, that you just rotate in that direction. Of course, a negative rotation is this direction. So I'm going to rotate, I suppose you could say, down. But again, negative 45 has always been in that quadrant. This time I'm just going to go out 4 radii. And we have ourselves another point, point B. I am going to give you some to practice, but I want to give you some more thoughts, because we're going to keep throwing around some negative signs. And this is where it gets a little more interesting. So this is why we're doing this lesson together, anticipating that we might not be together maybe in the next few days. So I really want you to focus in on this point right here, negative 3, 220. Now, no doubt that negative sign is going to catch your attention, and we're going to talk about it. But first of all, you can rotate to 220, and you're going to do yourself a favor if you just carefully go to 220. Okay, now 220 has always been 40 degrees past 180, so it's probably about right here, 220. Are you ready? Because what I'm going to show you right here, probably of all the things that happened this morning, this is kind of like the pivot point. Like, are you going to think about what I'm going to show you here correctly? You see, I'm actually not going to move forward 3 units. Let me say that again. I'm not going to move forward. In other words, I'm not going to move out this way. So which other way is there to move? Well, we call it the opposite. I'm talking about the opposite side of 220. So yes, I actually end up extending my line to the opposite side, and then I count, well, if you will, I count backwards 1, 2, 3 units. And that gets me to this point C. Now, what just happened there is how you will navigate a negative R value. And simply you will move backwards. You'll move backwards that many units. Everybody sees the 2 negative signs, but here's the good news. We're going to do just the same thing we've done the last few problems. We're going to first rotate to negative 300. Okay, now, again, anytime there's a negative sign, you got to be a little bit on your toes. A negative 300, maybe it wouldn't be bad to remind you that that would mean past negative 90, past negative 180, past negative 270. I'm just putting the negative numbers back on my rotation. So, geez, past negative 270, right? Yeah, all the way over here to negative 300. Okay, now if you're going to get these right, you're going to hold fast to what I'm trying to show you, that you do rotate to this position, which would be right here. But I'm not going to move forward 5 units. I'm actually going to move backwards. So yes, after I get to negative 300, I have to project the line to the opposite side so that I can, on the opposite side, count 1, 2, 3, 4, 5. And that'll be my point D. What do you think here? Something that you want to verbalize, especially about negative numbers, or just any questions so far? Because I'm providing you with like a little guide. It's actually got some stuff printed on it I want you to see. Since you're here, you get a hard copy. By the way, the homework is on the back. So that's nice. You also can access the homework in hard copy form. Now, normally what students like to do, and what I hope you want to do, is practice graphing any of these 4 points on the front. But I also want you to see some pre-printed graph paper. Now, there's kind of a lot of lines on there, right? Take a few minutes or a few moments and think about what each one of those lines represents. Some of them are labeled. Some of them you might need to label. But I want you to practice with this pre-printed paper. So you have to do a little counting of the lines. So try A, B, C, or D. See what you can do with any of those. Now, I want you to notice that each one of those polar planes is divided by 15 degrees. Even the one that's not labeled with numbers still goes by 15 degrees. Did you notice that? As far as the circles are concerned, the center is the pole. But the first circle would count as 1. So just in case that you need clarification, the first circle I have highlighted in blue. It's different because each of these graphs is different, but it's still the first circle. If you want to take a look, sometimes it is hard for me to draw. Some of it is just really just counting. But if you want to compare your first 2 points, you should have A and B. Take a careful look at letter B. Make sure that the point is actually on the opposite side of 60. So it's down there. It's down there in the bottom left side. Point C is actually pinned right there on negative 60. Point C stays at negative 60. Make sure you rotated negative 60 in the first place. And then point D is negative 30, but since it's an opposite of 5, I will actually have to go backwards 5 circles and end up ultimately right here at point D. But notice where negative 30 starts. Negative 30 is still down with a negative rotation. Okay, now there's a little more to today's lesson. This is sort of like the second phase. So if you're feeling like, okay, this isn't too bad, or maybe you feel like you wanted to start the homework, flip back over because there's more to this. I'm not going to change what we did, but I'm going to add something to it. Okay, and it's not going to take you too long to realize, oh yeah, what I'm about to show you is also true about letter A. You see, letter A was described with the numbers 2 and 315. But I actually could get to that point with a different angle, right? If you think about it, I could get to that point by rotating in the first place negative, or I should say negatively. So if I rotate negative 45, every one of you should agree that that is another way that I could get right to that point. But what I'm trying to say is that I could describe that point with a different set of numbers, simply with the numbers 2 and negative 45. But that's not all. Okay, that's not all. There's another way that I could describe that point. Now, this tends to be the other idea in today's lesson that's a little tricky, but let's try to focus so you can understand what I'm about to say. And that is that I could think about rotating to the opposite side. Now, the opposite side of my red point is over here at 135. And that does take a little bit of drawing the line carefully and correctly to the opposite side. But you see, since I'm going to rotate to the opposite side, which is 135, I could use a -2, which would then take me back over to that original point. But there's one more way. There's one more way that I could rotate over there to the opposite side. And it's simply by rotating backwards. Now you have to understand that that green rotation is still taking me over there to 135, but I have to think of it in a negative way. And in order to do this, it's probably going to be necessary for you guys to use some simple geometry. That simple geometry would be realizing that 45 degrees that we used a few moments ago is just going to transfer over here. So we can do a little bit of thinking about the green rotation. Now, it's a negative kind of thinking, right? So, it's really -45, if you will. But ultimately, I'm going to have to come up with the number -225, which is 45 degrees past -180. So -225 is another angle that gets me to the opposite side. And since I'm on the opposite side, I'll use a -2. Let's keep talking about this. I don't expect that with just one description that everybody's got it. And then maybe you're saying, got what? I'm not really sure what you're doing. But you'll notice that what I'm doing is finding other ways to rotate to this point. Now, if you go to letter B, one of the ways that I can rotate to this point is kind of like the original way. If I'm going to rotate to that point, I can just rotate in a positive manner. Now, this requires you to probably take some of the information that we already figured out and to kind of transfer it over here to the other side. I'm talking mainly about the 60 degrees, and realize that that's going to transfer right here. Let me see what color I want to use here. I guess we'll just put 60 right there. So if I'm going to do that black rotation, I have to rotate 60 more degrees past 180, and that's going to get me to the number 240. Okay, 240 is the rotation in a positive manner. Still going to be 4 radii. How else can I rotate to that dot? Well, I can rotate with a negative rotation. Okay, that would be this rotation right here, a negative rotation. Again, you have to do a little thinking about some basic geometry where 60 degrees seems to be a helpful number because I have rotated negatively 120. I've rotated negatively 120. And that's another way for me to get to that point. Now, the one that I gave you would actually be the third version on this list. So I'm recopying the one that I gave you. But the fourth version, the one that can be a little tricky, is the one where I realize that I want to rotate all the way around to the opposite side. Okay, but again, it's a negative rotation, so I have to be thinking of negative numbers. Use that 60 again. Use that 60 to help you get -300. Now, -300 is on the opposite side. That means that I'll use a -4 so that it swings me back over to the same side. There are 4 ways that you can describe a point. Okay, this is a little trickier, but I like to do this with you live, and I want to give you a chance, I want to encourage you anyway, to see if you can do this with letter C. Okay, now just relax a little bit, but realize that if you get this right, you will have listed 4 combinations. It turns out that the second combination was the one that I gave you. Let's see what you can do. I'm kind of curious what you picked up on. How else can you think about rotating to point C? Now you should be using 60 degrees as a helpful reference angle. Sometimes that 60 degrees can transfer over to the other side. Sometimes you can just continue to think about 60 degrees on the original side. If you're not sure, it's all right. It's part of learning, but I encourage you to try something and find out what it is that you're not sure about. Are you rotating different ways to get to that point? I don't know if we're going to have time to do this for point D right now. That black rotation, it started at 0. I basically went all the way around, but stopped short at that 60 degrees. That means I went 300 degrees. That black rotation is 300. Now, the other positive radius has already been given. So what that means is that we're ready to think about the other 2 options as the options, and these are a little tricky, but it's the options that are on the opposite side. Now, when you're on the opposite side, you kind of have to be thinking about this purple line, which happens to be at 120, which is actually one of your options. Like, to use 120, you're going to get to the opposite side. But since you're on the opposite side, you have to use a -3 to help you go backwards, back over to the original side. Okay, so take a look how I rotated 120, which again would be denoted with this purple rotation, just a straight rotation. It's this last rotation that you have to understand is going to take you to the opposite side, but it's going to take you negatively. Now, it's not -120, all right? It's not -120, but you can use, sorry about that, you can use 60 degrees and some basic geometry to transfer 60 over here. Okay, again, I'm kind of using that original 60 degrees, but I'm transferring it over, and I'm going to go 60 degrees past -180. 60 degrees past -180 is -240. -240 is the other way that I can rotate to the opposite side. Now, there's always going to be 4 ways. Have you noticed this? There's always 4 ways that you can describe a polar point. You can describe it with a ++. You can describe it with a +-. You can describe it with a -+. and you can describe it with a minus minus. Some people like to put down those 4 plus and minus signs. They also look like the original emojis. Okay, you got like the open eye, smiley face, the first one. You've got some winking, and then you've got my favorite, kind of the glare. So, but those 4 combinations will always work for a polar point. Keep thinking about this. The homework helper, that's your next place to think about it. It's on the back of the paper. Again, if we're not here tomorrow, we'll be discussing this through like hybrid lessons. So obviously tune in, as we already talked a little bit yesterday.